Test 1, 2, 3.
Hello, test. E bine. Mai vezi, înseamnă că e...
1, 2, 3. Când nu se vorbește, să fie închis. Pentru că bateriile, dacă stă non-stop on,
Mă auziți? Cătălin,
Da.
1, 2, 3, probă. Se aude la voi?
Da, da, se aude.
Bun, ideea e că eu nu vreau să se audă la voi, deci mă voi da pe mut aici, dar voi nu trebuie să dați pe mut. Voi trebuie să vă auziți în online. Eu nu trebuie să mă aud în online și nici cei de aici din sală nu trebuie să vă audă pe voi, că iese over nu știu ce. Dar la voi să fie ca și cum totul e ok. Atât timp, înțelegeți? Oricum ajung acolo sus. Gata, mă dau pe mut.
Bine.
Hello. Good morning, everyone. You can hear us. First of all, I'd like to mention that I'm very happy to be here again at this conference, and we could notice that this conference was growing from year to year. So, and also this year, we could present a very valuable panel in this morning, and I welcome everyone to this this session. And I welcome the presenter, Professor David Black from ECU, Edith Cowan University from Australia, Sukumar Ganapathy from Florida University, and Lasse Berntsen from Norway. I'm Dima Levente, the chairman of this session from Alba Iulia University here in Romania. So I'm very pleased to be chair of this session and to give the opportunity to presenter to make us familiar with their research and their approaches related to the smart city, smart education, and to have a fruitful discussion today related to this issue, because we are living in a changing world. So the technology is changing fast, the people are changing, the political situation is changing in every part of the world. So what we have to do is to adapt every day to this changing world. And this monitoring system, this approach to make our life better, to make our city better to live, should be our everyday goal. In this respect, I introduce the first speaker of this morning session, Professor David Black from Edith Cowan University, from the Center for People, Place and Planet. And he will speak about remote environmental monitoring based on IoT with valuable research result done in the southwestern part of Australia, if I'm correct, in the middle of the rainforest from there. So I'm a little bit familiar. I'm cheating because I've been there. So we've been there together, and we were inspected these sites where this research was performed. Few of them, because Professor David will explain us the areas where the research is going to take place. But what I can say, this is an interesting approach, and I'm very curious to see the results of their teamwork, because it's not one person's work in behind, because the Center for People, Place and Planet acquired together a large number of researchers, a large number of community members, and what I like very much also, First Nation is involved in this project. Native Australians are involved, so they have an important role in this project. So, Professor David, you have the floor.
Thank you, Levy, and thank you to the organisers for the Smart Cities Conference and for the invitation to present here today. It's a wonderful opportunity, so thank you. A little bit about me to begin with. So I am an Associate Director for a strategic research centre called the Centre for People, Place and Planet at Edith Cowan University in Perth in Western Australia. A little bit about the centre. So as Levy mentioned, it's a transdisciplinary research centre. So it is built around having multiple disciplines come together to tackle some of the issues that we're facing, both within Western Australia, and globally as well. So we have researchers from arts and humanities, we have from business and law, from our West Australian Academy of Performing Arts, from science, and from education. And so, yes, we have that transdisciplinary research approach. So the centre, what it sets out to do is to co-design research and action with and influenced by Indigenous knowledge holders. And so today I'm going to take you on a bit of a journey through a couple of research projects that we're undertaking in Western Australia. And I just want to point out that those research projects are actually co-designed and co-led with Aboriginal colleagues. And so we also do transform human-environment relations through place-based research. So all our research it takes place on what we call country. And we recognise living systems where we have interdependencies and mutualities, and to strengthen governance and management for sustainability. And so we have 3 programs of research. The first one is food, earth and water resilience, and that's mainly where my work takes place. Our other programs of research include feminist, creative and place literacies for eco-social transformation, and transforming responses to global environment problems. Before I begin, I will apologise if I'm not communicating very clearly. So I only arrived yesterday and after a 20-hour travel, and I think my brain is still trying to catch up with my body. So, but today I'm going to talk about smart living in remote places. So as you'll see in a minute, Australia and Western Australia cover very large areas, huge land masses. And a majority of that land mass is what we refer to as rural or regional. And there are not that many people that live there, but we need the information from those areas to help make land management decisions in those areas. So of course, smart living is data-driven decisions, so we need that data to be able to make those decisions. Of course, in urban environments, Internet of Things has been a great success, and a majority of probably 70% of IoT projects take place within an urban environment where you have the infrastructure to support those types of systems. But what about in remote areas? As I said, we need that information, we need data, but how do we actually set up systems where you don't have very good connectivity? The conditions are quite harsh for deploying equipment, etc. So I'm going to give a couple of case studies today about some projects that we've been working on and how we've used or implemented IoT systems to help us collect data in remote regions. So it matters in environmental monitoring. It matters for a whole number of reasons, as I said, but for acquiring data in particular. In those areas that I'm going to be talking about, we have a large agricultural sector. A lot of our wilderness or conservation areas also occur in these rural or regional areas as well. And then, of course, we need to be prepared for disasters, and in particular, you may be aware that Australia is prone to both fires and floods. And so we need the information to be able to act quickly, particularly in remote areas, particularly where we have our First Nations people, where they may not have the access to a lot of the infrastructure or health facilities, etc., that we enjoy in urban centres. So we need to have systems that enable us to be able to provide them with the care and access to resources that they need. As I said, the accessibility is poor in those areas, and a lot of the data or a lot of decision making is done without the knowledge or the data to be able to make informed decisions in those remote areas. And these are the areas that we actually particularly need it in Australia and in Western Australia. So what is the challenge with deploying remote IoT systems? You have sensor gateway connectivity. Again, we're talking vast distances, and so how do we connect sensors and multiple sensors to gateways that then can feed that information centrally? How do we connect our gateways to the cloud? And of course, we need connectivity to do that. Power management, again, we're in regional remote areas. We don't have access to power where we can just be able to plug them in. So we need to develop power systems that can power them remotely and for extended periods of time. We have very harsh environmental conditions. We typically have summers in the areas that I'm working with temperatures regularly above 40 degrees Celsius. Again, and then there can be saline conditions as well, so a lot of salt in the environment. They can be acidic, So we have quite harsh environmental conditions that can be harmful to sensors and equipment. Validating your data, the high cost of actually traveling into the field to collect data. So as I'll point out, both our field sites are 1,000 kilometre round trips. So you can't just go out and actually collect data on a regular basis. And there are limited real-time capabilities. So to give you some context about Western Australia, the land mass of Australia is about 7.7 million square kilometres. To give you some idea, this is the number of countries that can fit inside Australia. WA, which is where I'm from, is about a third of that. So Western Australia is 2.6 million square kilometres. So we have a large expansive area. As you'll see from the map, our urban area is that small white area down the bottom in Perth and Bunbury, and that's where most of our population in Western Australia is concentrated. And so the rest of Western Australia is considered rural or remote. And so this is the places where we're trying to conduct a lot of our research. So we're located hundreds to thousands of kilometres from other cities. So Perth is probably one of the most isolated capital cities in the world. Our next nearest capital city is 3,000 kilometres away. So to give you some sense. So when I say I travelled 20 hours to get here, it's not unusual for us to travel a long way to get anywhere. And one of the main issues is connectivity is patchy. So once you move out of that urban environment, being able to connect to mobile data systems or even satellite systems, it becomes difficult and quite patchy. I'm going to talk about two case studies. The first one's in a town called Perenjori. It's an agricultural town. It's situated about 350 kilometres northeast of Perth. And as I said, it's about 7 hours round trip driving to get out there. And then the second one, I'm going to be talking about where Levy has been, and this is the Walpole Wilderness area in the Great Southern area of Western Australia. Again, it's about 1,000 kilometre round trip to get to our study sites. The Walpole Wilderness area is an area where we have peatlands, so temperate peatlands, and our research is involved in trying to preserve or conserve these peatlands. So the first study was about, in Perenjori, is a study that was called Transformational Aboriginal Agricultural Methods, or TAM. And this is where we partnered with Aboriginal knowledge holders and elders to actually help come up with a plan to try and control the flow of water across the landscape, which you'll see is a big problem in a minute. And as I said, 350 kilometres northeast of Perth, we're operating on 2 farms out here. To give you a sense, the annual rainfall in this region is probably 300 millimetres within a year, and the 2 farms get half of that. So probably about 150 millimetres a year. So a really very dry and harsh environment. And when they get rainfall, it happens very quickly. They get it in very large downpours, and it causes a lot of erosion issues, as you can see here. So what we get in the landscape is we get these big erosion gullies or erosion channels, and it just takes all the topsoil away. And this is a big problem for the farmers. And so we had our Aboriginal colleague come in who I've connected to the land and both spiritually as well as physically. And so they're able to provide guidance and information about how we might implement these things called leaky weirs to actually control the flow of water across the landscape and try and prevent it from taking all the topsoil away and having water remain, as they refer to it, as on country. And then if we can slow that water down, we get vegetation growing and repairing a lot of these erosion channels. So our job was to actually provide some science behind these interventions. So our Aboriginal colleagues would build the leaky weirs, try and control the flow of water across the landscape, and we were tasked with trying to put some numbers behind, is it working and how successful has it been? To be able to do that, we had what we call 3 intervention sites. So there was 2 erosion channels on one farm, and then another single erosion channel on another farm that we used. At each of these sites, we set up 6 plots and we did soil analysis, etc. We also measured soil microbiome and did carbon gas flux measurements. But more importantly, we implemented an Internet of Things soil moisture network at each of the sites. And then we used drone survey to acquire information about biomass, etc. So these are the sites, and these are where we set up our different monitoring sites. And so the Internet of Things consisted of a LoRaWAN gateway. We had 1 on each farm. We had multi-depth soil moisture sensors, so up to 1 metre, and they are measuring, I think, at every 10 centimetres in the soil profile. And then to complement that, we had rainfall gauges and temperature and humidity sensors set up as well. And so at each of those 6 sites, or at each of those 6 plots, at each of our sites, so we had about 18 different sensor systems scattered over the 2 farms. As I said before, powering these systems is difficult. They're remote. There is no way to just plug into the electrical system. So we needed to set up a portable power system for them. And you can see in that image on the right is how we do that. The LoRaWAN gateway is actually just attached to a branch in a tree at a high point on the farm. And then we have a solar panel connected to a 100 milliamp lithium battery that has a regulator that can continually charge and power the gateway. And then the sensors just communicate to the gateway. And so this is some of the sensors we're using. We use the multi-depth sensors came from Sensorterra, and we also use rain gauges, temperature and humidity, and some soil moisture sensors from Sensimo. And we, again, they all were integrated together. What was it able to tell us? Basically, some insights were, particularly for the farmers, that the top 30 to 40 centimetres of the soil profile is completely dry. So trying to grow crops, wheat, or any annual crop is almost impossible in these systems. They do it, but it's very difficult for them because it doesn't retain moisture for very long. What this was able to tell us was that there is a lot of moisture actually deeper down in the profile. So if they were actually to plant more perennial type plants, etc., that can access that water, and which one of our farmers was actually doing, it has a great deal of benefit for that system and to improve soil health. What it also showed us, and you can see the red line, is the leaky weirs. After they were installed, it actually changed the soil moisture profile in those systems quite a bit. So that told us that those leaky weir systems were working. And these graphs can just show you as well that how the surface soils were responding to rainfall. So they respond very quickly in the top 10, 20, maybe 30 centimetres. It takes longer for the deeper soil moisture profiles to respond, but they do, and then those changes persist for longer. Okay, the second case study is actually on conserving temperate peatlands in an area called the Walpole Wilderness Area of Western Australia. It's a very large project. We have up to 21 scientists working on this project from different discipline areas, and we work collaboratively with Aboriginal elders and different community organisations as well. It's quite unique. It's one of the only, or very few, wilderness areas actually declared in the Southern Hemisphere. As I said, it's about 500 kilometres southwest of Perth, and it's in a high rainfall zone of Western Australia. So these peatlands form in an area where we have about 800 millimetres of rainfall per year and very high humidity, so 70 to 80% humidity in those areas. So it's in the southwest, in the deep southwest of Western Australia. We have peatlands scattered throughout there. They're poorly mapped and they're poorly understood. One of the biggest problems we have for those peatlands is fire. So this is a fire that was started intentionally in April 2024. I can't remember the exact area that it burnt through, but each one of these plumes that you can see in this photo is actually a peatland that is on fire, and they will burn for months. It's almost impossible to put them out. And you can't even get access to most of them. So the amount of carbon that is being released is significant from these systems when they catch fire. One problem we have is that our conservation agency, our government agency, also use fire as a management tool. So they actually put fire through the forest to try and reduce fuel loads, but because of climate change, when they do this, a lot of the peats are now catching on fire. So we need information that can actually inform them about when the peats are vulnerable to catching fire. So that's where we came in. Again, we set up our IoT systems, very similar to the last case study I showed you. This was our first iteration of a power supply unit up in the top image. And again, we just have the LoRaWAN gateway attached to a tree. And then we have a lithium battery powered by a solar panel. And then we connect all our sensors to that. A couple of the issues we have both on the previous project and on this project is with the power supply units. Our first iteration, which is the one here, it got blown over in storms, etc. And actually, so our system stopped working after a while. So we have to go down and try and repair it. That's where we came up with a different design that's a bit more robust. Vegetation's obviously an issue in these peatlands. We have a lot of heath type vegetation. It's quite dense, so getting the sensors to communicate with the gateway is a bit of a problem. And what I didn't mention in the previous study, in the agricultural study, is that we have a lot of sheep and goats, and they love to actually eat cables and things like that. So we had a lot of our sensors that stopped working because the goats or the sheep had actually eaten the cables. So all that information we get fed into a things network, and then we're able to access the information remotely, so we can access it in Perth. And this is just some examples. This is all our sensors for temperature and humidity. An example of the soil moisture information that we can get. And this is just some rainfall data as well that we get in. And then this is from Sensorterra, and I'll talk a little bit about that in a moment, but this is the soil moisture graphs that we can see, and we can monitor how they're changing in the soil profile. And this is just some examples of all the scientists out in the field, in the wilderness area, working on peats, etc. We have very rare flora and fauna in these areas. Rare frogs and lots of rare plants as well. So it's very important that we conserve these areas. So what are our key learnings? A lot of the barriers, connectivity is an issue. So in both locations, we're operating on 1 bar of 4G signal. So we're relying on that to be able to communicate all our data from those areas. In the peatland areas, there are some areas where we cannot get any connectivity at all. So we have to place the gateway where we can get connectivity, and then hopefully the sensors can communicate that distance to that gateway. So it is a problem. The other option is to use something like Starlink, but that becomes very expensive. Power I've already talked about. The resilience of the hardware and being able to be left out in remote locations for a long period of time. And most of the sensors in that we've used and the gateways have been able to remain operating in those conditions as well. Different pressures for agriculture. We have a large spatial footprint, long sensor chains. So we're trying to communicate from sensors over a long spatial area. It's easier in agricultural areas because you don't have a lot of vegetation or infrastructure that will block the signal. In the conservation areas, we do. So sometimes connectivity between sensors and gateway is a problem. The other thing is sensitive environment. So we don't want to be going into those conservation areas all the time because I said we have rare flora and fauna species. We want to keep our impact quite low. The benefits of having these systems, we get early alerts, we get information, we can use that information about the peats to inform the land use managers of when to put fire through the areas or when not to. Reduces our travel costs, obviously, and it's safer for us to be operating in those systems. Those systems themselves need to be quite simple. We try and keep them as simple as possible. The more complex they become, the more difficulties and issues that you face. They need to be robust. Okay, and then if we were to design a system for IoT for remote work, assess the environment. So you need to design a system that's suited to the particular climate and terrain that you're working in, and also for accessibility, etc. Choose the appropriate connectivity. In our case, it's LoRaWAN, but in other systems, there may be different connectivity approaches that are better. Resilience, actually build resilience into your system, and not only through the hardware and software, but also have some redundancy in the system as well. We have lost quite a bit of data where we've lost connectivity. So we actually have static loggers out as well, so that when the system falls over for whatever reason, we can continue to collect data during those times. And the final one is data sharing. So I showed you before, this type of system, this Things network, and we use Grafana to develop our platform, is great for us in being able to monitor the system. It's not very user-friendly for third parties, such as farmers or for government agencies. So our issue at the moment is developing a system, a dashboard system that is user-friendly, so they can have, it has more data analytics built into it, so they can actually access information like those graphs I was showing you before between rainfall and soil moisture levels, etc. That's it, I think. Thank you very much.
Thank you very much, David, for your interesting presentation. If there are any questions or comments related to this presentation? Yes, please.
Okay, thank you. It was a very interesting paper, and from the point of view of regarding the safety of the equipment, how do you manage when you have an overload of the solar panel, of photovoltaic panel that you have there? Because sometimes, because you said it's a very remote area, and if you have a overload of sun, or doesn't they catch fire, or isn't this a problem? And how do you manage the consistency of the cables? Because if they are exposed to a higher temperature all the time, they will have a lot of tear. And how did you manage the wildlife or the animals that are arriving in that area? Do you have implemented something that will keep them, like vibration or sounds or different aspects that they can, for example, in industrial sites, we have a different system that we implemented, for example, on the roof. So the birds, that they will not come to the area where we have different chemical substances. So I don't know if this is the case here. I'm just curious because it's very interesting. And
so the first question about solar panels, etc., we did a lot of testing, and we actually did it in Perth before we deployed them. There was still a lot of trial and error. Fire was a concern, so we had to make sure that we can keep the batteries shaded, stop them from overheating, particularly in summer, etc. And we just make sure that we have a box that's designed to try and be as weatherproof, etc. There's no way of actually, well, I shouldn't say there's no way. We actually, in our second iteration, we put in sensors that will tell us the heat, etc., of the battery. And so we can monitor it if it's starting to overheat, etc. Not that would be nice, not remotely, but we have people in those locations that we could send them out to disconnect the system if it was needed. The issue about the sensors and cables is an important one. So I don't want to be critical of SensorTerra because they have quite a good product that we're using. However, cables was a big issue, particularly in those environments. So we've been able to feed that information back to them, but again, we had to replace quite a few cables. The benefit of the cables is that they're able to increase the height at the sensor can transmit to the gateway, which was important for us, particularly in the peatland areas where we had to get up above the vegetation sometimes. So those cables are really important. Probably the worst issue was in the agricultural. As I said, the sheep and goats came in and they would actually go to the sensors. They'll rub up against them, they'll knock them over, they'll chew on the cable. And we only know because we can see the signal stop coming through from those sensors. So we just manufactured a physical barrier just out of wire. But again, we're trying not to impact the system too much that we're measuring. So it's coming up with something that's not going to impact how rainfall infiltrates or anything, but is a deterrent for those sorts of animals coming through. Sheep is not so much, but goats are a real problem. The goats are not farmed, they're wild. So it is difficult, it is a problem. We need to be careful with deploying devices that emit some sort of sound or because we have a lot of wildlife and natural animals around that area as well, and we don't want to impact on those. So at the moment, we think the physical barriers are working and it's probably our best solution, but it's a lot of trial and error. One thing I'll just talk about quickly is with SensorTerra and a lot of other companies, they have their own cloud-based system, and this is a problem for us. We're trying to integrate their system into our system. It is not, and their system is designed so that people pay a subscription to get information from their cloud system. So it's not easy for them to share data so that we can integrate it into our system. So that is a big problem. They have very good sensors that we would like to use, but actually accessing the data in a format that we need is quite difficult. They want us to pay the same as any other person for subscription, and it becomes cost prohibitive then to be able to do that. So, and the other thing is then when you're using sensors from multiple different manufacturers, you have an issue with actually integrating all the different sensors into your things network as well. So that's been a bit of a problem as well, trying to integrate all those. Thank you.
Okay, thank you very much for your answer. So I would have a small short comment related to the sensors security integrity, because I was thinking several times to implement in Romania such a things, but beside the wildlife and animals, here is also the human factor, because sometimes they consider the sensors as an unforeseen fortune, so and they collect them and they reuse for personal purpose. I don't know what they could do with a water sensor or the humidity sensor, but they collect them from the field because it's not protected, it's not guarded somehow, and it is a big issue in Romania because in Walpole is very far away, and you have to be a very expert to find that sites with where the sensor are. So you have to go up in through the rainforest, and I should tell you that the rainforest is not like the forest in our site. It's quite difficult to go through through the bush area. There are snakes and other things, but they are somehow protect themselves there. But here in our area, it's very difficult to hide those sensors from the human eyes. And for the final, just a very short question. So you collected a lot of data from agriculture field. Can we say, or is difficult to say that we can declare somehow the failure of the modern agriculture in Australia? Yes.
I think Australia, a lot of Australians know that European agricultural methods have not been successful in that landscape. It's a very ancient landscape. The soils are very old and they're very depleted in nutrients, so they don't have a lot of nutrients. The vegetation that was growing there has adapted and evolved to grow in those types of soils. We've removed all that vegetation. We try and grow annual crops using European methods, and it's destroyed the landscape. So we have a big issue in Australia at the moment with producing food and food security, because a lot of our agricultural area is now struggling under climate change in order to be able to produce and continue to produce, so they're putting more chemicals onto the system, which is further destroying the health of the system. So working with Aboriginal people and doing the type of studies that we're doing is helping to understand what's required to actually build up resilience in the soils to continue to produce food into the future under very trying conditions.
Thank you very much. You didn't express that is a failure of the modern architecture of agriculture, but your answer lead us to understand that return to the root would be helpful for the sustainable agriculture. Thank you very much for your presentation and for the discussion. What it follows, I will introduce Professor Lars Branson from University of Southeastern Norway, and he will present an interesting issue related to generative AI in action, transforming ideas into real-world value. So AI is a presence in our everyday life, so we are very anxious to see your findings. Professor, you have the floor.
Yes, thank you. Thank you. So I'm going to talk about a project that we are currently doing with one of the municipalities in Norway city of Sandefjord. Let me just, not working? Okay, so I just have to tell you when you, okay. On-off button. So I'm a professor of information systems at the University of Southeastern Norway, and I teach AI management, business analytics, which is basically also AI, and IoT. And I do research on smart cities and energy systems, sustainability, and AI. So actually, we have only 3-4 days ago, we had the anniversary, 3-year birthday of ChatGPT. And it feels like it was much longer since we had this, but you know, things are happening very fast nowadays. So just to think that it was only 3 years ago that we got ChatGPT, so it's very special today. So of course it's a big race about this generative AI, and we have competitors among all the big ones. So Google got Gemini, and Microsoft got Copilot, and we have Grok and Perplexity and DeepSeek and a few others that are competing of being the first one. So it's a race. So what is generative AI? This is generative AI. It's a picture of myself. It's a branch of AI focusing on creating new content, and it learns patterns from data sets and produce outputs that resemble them. And it can be text, images, music, video code, and so on. The project we are doing is in the city of Sandefjord. It's located 120 kilometers south of Oslo. And every year they do around 70,000 decisions regarding care services. So it means that if you are old or you have some impairments, then you will apply for some services from the municipality. And it's 70,000 decisions a year. So it means that it's a lot of work. And we also have a division of responsibility. So the people that are allocating the resources is not the same as doing the service provision. And this is just to ensure that the allocation is fair. The people in this office that allocates the resources, they are basically collecting information about the patient, and then they are making the decision based on this information. If we have done a study, I had a master's student that worked on this project last spring, And what we found that it's a lot of repetitive work and boring work for the employees. They express this, and I will get back to that later. But it means that they are basically trying to find some similar case from earlier, and then they copy paste into a new document to make the decision, and then some quality control by the manager and so on. So our project focus on what is called RPA, robotic process automation, and using AI-driven tools. And we also have a lot of ethical considerations since this is in the medical field. So we have a lot of rules and laws and regulations about this. This is what I said about the division of responsibility. So the resource allocation is not the same as the service delivery. It's a kind of a big wall between those, just to make sure that everyone gets a fair treatment. Process automation is basically a workflow system where you fill in some form and you add some data from databases, and then you have some review and you make a decision. This is already implemented in the municipality, so they have now implemented the RPA system to handle this thing, and the next step is basically shifting to AI. I will get back to that. So robotic process automation is not like this, it's more like this. So RPA is taking data from one application and or two different applications and moving it into a new application. So it's basically automating the cut and paste process. So many companies are using RPA to automate back office workflows and make decisions with rules. But an increasing number of vendors are combining RPA with machine learning to make better decision making, and this is called intelligent process automation. And this is what our project is about. So we have used this year to review all the existing procedure and guidelines, and my master student did what we call work shadowing. So she followed the workers on a day-to-day basis, and we also have interviews with the employees. And I will now present some of the findings. So this is basically the situation today. It's a lot of repetitive work and boring work, and that is why these people are so depressed, because it's not challenging, and they want challenges. They want to work on the hard cases. They don't want to do cut and paste from existing documents. So, as I said, repetitive work, routine work, time-consuming processes. We have a lot of low-hanging fruits here to make things better. These are some of the comments from the employees. Like they say that, okay, I need to search address lists to find the correct zone responsible for carrying out the service. It's a lag in the journal system. Sometimes I have to wait 30 seconds between each click. And another says the dream would be if AI could automatically enter all the information from the application or assessment and sort this. It would save a lot of time. What we also found is that the employees have quite positive attitudes towards AI. So, like one said, I'm positive about trying it out in my job, hoping, among other things, that it can ease my work days in terms of writing the decision letters. Of course, some worries about losing their jobs in the long term, but again, it's a positive attitude because they want to work on the more complex cases and not do the repetitive, boring work. It's also a lot of concerns among the employees about ethical considerations. They are concerned about that AI systems must preserve the dignity of the patients, and decisions should be made on individual data. Also, they want to transfer their professional discretion into the system, and one employee said that justification must always be based on individual assessment and consider exclusion criteria. Again, they are quite positive to automation because of this repetitive work and often boring work, this cut and paste. But they also say that okay, we must have the possibility to override the system when necessary. And of course, training is also important. I said something about the more complex cases, and also the employees, they are concerned about the complex cases that sometimes they also need some human considerations. So this is based on our work with the employees. RPA and AI should support, not replace, professional discretion. We need to involve the end users, that's employees, early, so they can be involved in system design and testing and training. This is a good system development practice. And also prioritize socio-technical fit. They must not only be efficient, but also socially acceptable and ethically grounded and usable within the context of human routines and expectations. So we have already, RPA is implemented at the moment. So it means that some of the cut and paste is automated. But the next step is to use AI for analysis and predictions, and also to create decisions. And we have actually, for the prediction, we want to predict bottlenecks like when they need more people. This can be the time of the year, infection rate for flu, that kind of things. We want to put all those things into the system. And we can predict things about both patients and the caretakers, and this is the outcome. So if you remember the picture from earlier, this is actually how we perceive the employees and their opinions about, or their hopes for AI. But this is not only a mapping of the opinions of the employees. We have done more than that. We have done a proof of concept, and we can actually show that this is possible to do. And this is actually one of the application forms. This should be a movie. Can you see, Lumnita? Can you see if it's possible to, if there's a movie? Yes. So what you see here is actually a front end to ChatGPT. We fill in the information regarding the patient, and we should see that there's something. Yeah, just turn it on. Yes. Because somewhere you will see that, okay, it's now generating the decision. And you can see that, okay, this is generated from ChatGPT. It uses a template, and it creates a decision based on information from the corpus from earlier decisions. This is another one. So if you can start this too. This is a rejection. So it's also a movie. And since this is a legal thing, rejections is more voluminous because you need to say why, and you need to talk about the possibility to complain and all these kind of things. So it's more legal things that is in this system. So we have shown that this is possible to do. We use the ChatGPT API to put the data in. And also, of course, this leads us into some ethical issues. We never share patient data with ChatGPT. Only the diagnosis, the information that is not connected to the person. So we only introduce personal data in the very last step. And that, of course, is important. The ethical issues, fair allocation, bias. We think actually that we need to be concerned about bias and fair allocation, but we don't see any indications so far that we got any bias in this context. It's using the information that is in the database and use it. So in this project, we also establish responsible AI policies and governance structures to ensure fairness, transparency, and explainability. And we also implement the model documentation and review process, and we aim to foster a culture of ethical AI innovation. So we have this human in the loop. It's not like AI is generating the decisions and making the decisions themselves. This is a tool to help employees, and it's always checked by the caseworker. So we don't see this as a complete automation, but it's more a tool to help them work more effective. And that is very in context with this conference, smart living, smart work. So we have this human in the loop, and as I said, ChatGPT never gets the personal information that is put in when we make the decision. And the human is overseeing this process. So I'm now getting to the end. We also want to use AI, and this will be the next year, to also do compliance and control. So we want to use ChatGPT to monitor that laws and regulations are complied with in the decisions and also report deviations. That's a very interesting thing. Because one thing is to generate, that is not very hard, but it's harder to do this kind of things. We also work on a dashboard to monitor the decision production and identify bottlenecks and processing times and complaints and feedback and all those things. So I made this risk profile, and the ones in green, RPA, the dashboard is quite simple. The yellow is the decision-making tools that we have already made a proof of concept. Yellow, because it's not that, we have shown that it's possible to do. And then we have this compliance and control. That is a more difficult thing, but I have 2 master students now starting working on this in January. So success factors. Of course, this would never happen if the leaders of this municipality didn't have the vision and commitment to use technology to make things better. And of course, when the top management is positive, also the employees get positive. We have some clear goals to be achieved. We experiment to show proof of concept. We also use the MVP, agile development. It means that we don't put in functionality that is not requested by employees. It's also important to see employees as a resource, provide sufficient training, and success is 20% technology and 80% about the humans. This is actually not my finding. It's from a book called All In on AI by Thomas Davenport. But I think it's very reasonable. So we have shown how AI can be used to create substantial value by removing waste. And by waste, I talk about these repetitive processes and cut and paste. So it's about lean thinking, and we get rid of the repetitive tasks and we improve the quality of the decisions made. So the conclusion is generative AI succeeds when technology, ethics, and human judgments work together. And thank you for your attention.
Professor, thank you for your very interesting presentation. If there are any questions or comments to this presentation? If not, I have a question. So related to a picture when all the people were happy with using an AI, but in the backward is not a fear of losing their job because of using of AI in the administration, in the public sphere. Is there this danger for?
I think this is very much about what the management is saying, and they say no one will lose their jobs because of this. We will just make the work situation better. So it's a promise, basically, from the executive director of the municipality and from the mayor that this will be a project to improve the workday and to spend more time on complex cases. And the municipality got a good reputation about keeping promises. So it's not really, of course, someone expressed that, okay, maybe it will replace some of our jobs. But again, we get more and more old people. So no one is really fearing for jobs in the health sector at the moment.
Yes, but once the spirit is get out from the bottle, it can be implemented to private companies, and private company is looking directly to profit and to minimize the cost. So it will be somehow a danger implementing this generative AI in the private sector, not in the public sector. So, and in this point of view, it could be an issue. Thank you very much.
That is true, but at the same time, we have a very strong legal system in Norway that protects the municipalities for outsourcing that kind of tasks, so it will not happen. Not in my country.
Thank you very much. Another question.
Not possible for AI or needs human supervision. For example, here is the aspects that are using AI in account and in finance departments. Right now, all the people that are introducing the receipts and all the documents, the financial documents that are in accounting, everything is done with AI. And in the next year or maybe 2 years, this position of manually the data in the accounting, the software, it will not no longer be. But right now, all the people are trained to do financial advising, how to implement the legislation, how to follow up on this. And sometimes how I see the use of AI is, for example,
Yes, it's true, and we can get more challenging jobs that way. So when we use AI as a tool. Yeah.
Thank you very much for your presentation, and I invite The next speaker of this panel, Sukumar Ganapathy from Florida International University. And Professor Ganapathy will talk about divergence in smart cities between Europe and the United States. I'm sure there are differences because there are differences between smart cities in Europe and smart cities in Asia or Middle Asia. So we have divergences, and I'm convinced that there are also divergences between Europe and United States in the term of the smart cities. Professor, you have the floor.
Thank you. Well, how about I start with saying that there are no smart cities in the United States. That could be a good kind of a controversy to start off. Well, in a way, that statement could be true. I do get a lot of applications from across Asian, European, as well as Latin American students that they're interested in smart cities, studying smart cities in the United States. And then I have to look at it quizzically because we don't have a smart city policy at the national or the state level. So that's where some of this conversation starts to become happening. So I teach in the Department of Public Policy and Administration, and this is at a much kind of a more abstract political and less of a technical conversation as compared to both of the conversations we've had earlier. And this is at a much larger level of how these conversations are happening in the United States versus what's happening in the Europe. And I hope there is some kind of value in that conversation. So I'll go into what some of those big concepts, conversations are in terms of US and EU smart cities, looking at how these smart city dimensions happen across the United States and Europe at a very, very broad aggregate level. It's not at the individual city level. And then looking at, again, the broad brush of how these differences manifest themselves at the governance, the planning, the innovation models of how these smart cities emerge. And then look at a few key challenges which are happening both across Europe as well as the United States. So if we look at some of the very conversations happening on what are smart cities. So let's start with the smart city indices themselves, right? If this is a list of the top 10 smart cities from two of the folks that do these kinds of indices. You can look at them with a little bit of a quizzical eye. This is not necessarily the be all and end all. But having said that, there is this kind of a conversation which is happening as to what these are as smart cities. And you can see from the IMD side, which is based in Zurich, none of them are in the United States. From the IESC side, the three of them, again, you might question whether New York really is a smart city. DC, is it really a smart city? San Francisco, yes, maybe when you get off the airport, you can feel it. It's tangible, it's right there, it hits on the face. You walk around the city, there are way more cars, which are self-driving cars all around. But again, the question remains, is San Francisco a smart city? When we look at it in terms of what smart city is, more broadly, there are these kinds of various dimensions which we talk about in terms of smart mobility, smart environment, smart people, the smart living, smart economy, and the smart government, right? It's kind of the different dimensions on which we evaluate or think about smart city. And again, these are not necessarily the end of the conversation in terms of the smart city dimensions, but the main idea is that smart city is not just technological. It's all about people. It's more about integration of the people into this. But technology is the core focus. And if you look at it from an American perspective, it's only about 15% of the smart cities in there. And what do they focus on in terms of the smart is the mobility dimension, like the Waymo cars, right? The self-driving cars, these are technological innovations which happen, use of drones, the GPS and the GIS kind of technologies, which are again facilitated because there is a lot of technology, there's a lot of data, there are a lot of sensors which are set up across all these places. A lot of these smart cities in the United States are also driven by what Silicon Valley does. Silicon Valley wants to demonstrate what its value is across these places, and therefore you have these kinds of innovation and tech startup systems. It's a very, very market-driven approach, and that we cannot lessen in any way. It's all about how there is a partnership between a private sector agency, be it Google or Microsoft, or even we're talking about ChatGPT, how that's adopted into the smart city framework. It's not about the city itself. It's about that particular private sector partnership. And again, a lot of those focus, if we see, is on those operational efficiencies of either in terms of mobility, how we get from point A to point B more efficiently, or how we conserve energy, and so forth. So it's all about efficiency, which also, again, in the era of what we are living in with the Department of Government Efficiency, that is one of those pieces that comes into play. And this is where the contrast with the European, and you can correct me if I'm wrong in many of these, is you have a lot more of these happening in a much more policy level, not at the individual player level. And there's a lot more of a focus on the environmental side, which contrast, that's not the case with the Americans. A lot more of a focus on the people, which contrast is not the case with the Americans. Yes, there is a lot more of a focus on smart mobility, again, more coming from an infrastructure, environment, and other perspectives. And given how European focus has been on the GDPR, on general data and privacy protection, the data security matters a lot. The data security is not what matters for the Americans first. That is, whatever individual data is, that belongs to either the private company or whoever is collecting that data. There are much less of those protections. Yes, there are some of those protections coming from California and a few other states, but at the federal level, there's no such privacy protection. There are a number of bills which have been under consideration. None of them have passed. Private sector companies would like to have a federal policy, but they are dealing with more of these state level, and they cannot deal with each of the state by state policy level pieces. So what does that mean in terms of the comparison? When we look at the United States, it's much more of a competition based, which means it's much more piecemeal across. Whatever a private sector can get in terms of partnership with the city government, that happens. It's not at the state level. It's not at the federal level. There's no such kind of, again, going back, policy which is across the board. So it's a much more market-oriented, much more decentralized approach with very little federal or state coordination. When you're looking at the European side, you do have a lot more of that, right? The EU is putting its footprint across the board. You do have a smart city policy, which kind of works across the board, which is not the case, again, if you look at it from a federal side, for the Americans, the National Science Foundation has a smart city initiative, more in terms of, again, competition, that whoever applies for that gets certain projects. It's in Europe, it's much more government-led, policy-led across at much different levels. Yes, you might have differences within the European countries themselves, but I would compare to what the Americans have a much more emphasis on the inclusion and equity. That, especially under the current administration, that is a no-no. And where I come from in Florida, that is much more of a no-no. In terms of the city models also, if you look at it, on average, American cities are much more spread out, low density, car-oriented suburban neighborhoods, which is why we see a lot more of those emphasis on Waymo and personal-driven vehicles. And these are very, very spread out. Miami itself is a spread out. Los Angeles is a quintessential spread out city. With all of these kinds of sprawl developments, what does that mean to have these sensors across? A lot of those then comes into how the transport infrastructure is using these technologies. It's not in any other big way. For European cities, it's you can see for across Europe, on average, it's more compact. Amsterdam is much more dense than Miami for sure. Shorter average distances, a lot more of an emphasis on walking, healthy walking, right? We are, even in the last 3 days out here in Romania, that's what I'm seeing, much more of a walk, which is alien to us. And much more of the efficiency aspect in terms of those, not necessarily in the financial side. So coming into the innovation side, again, this could be an upside or a downside, depending on how you look at it. The Silicon Valley tech ecosystem and the venture capital is pretty much runs what the smart city is. It's a commercial enterprise. It's not a public enterprise. So in that sense, whatever is paying, that works, right? There are advanced mobility technologies which have developed because of that. The drones, for example, are supported by Amazon for remote delivery, and that's why a lot of that development is happening. The data analytics and AI implementation at scale, that also is happening mostly because of those private sector markets. It's not because there is a need from a public sector side. And also from a commercial side, it is much more of that, more of how you can scale those small solutions into big solutions. On the European side, you do have a lot more of the sustainability focus, right? That's not necessarily on only the ecosystem of what that tech infrastructure looks like. Robust kind of data privacy frameworks, as we were talking about, citizen-centered technology design, and even on the digital twinning side, I hear less of a conversation on that happening on the American side than on the European side. Although the potential for the twinning is a lot. And most of that focus is on the research side, not on the urban side. So key challenges from both sides, obviously smart cities are not cheap. It requires technology, it requires infrastructure, it requires change. AI is not cheap. We need to have very good infrastructure for that. These are not cheap in terms of consumption of electricity. They require a lot of electricity. That is potential for digital divide, although we see that divide both reducing and increasing across different kinds of technologies. Interoperability has been an issue across the last 30 years. It's not something new. Cybersecurity is, of course, a lot more growing, and that's one of my areas, which is for a different conversation, but that's the threat which has been stable, and the data protection requirements are not as robust. So when we look at it in more kind of specific areas of how it is different between the United States and the European Union, it is that the United States is much more fragmented. It's each city by city. It's not a policy-wide. It's not federal. It's not state. European Union, more or less, again, given whatever the differences might be between between the countries and at the regional levels within the countries, there is a lot more of what that balance is with innovation, regulation, and so forth. So I'll just kind of conclude with some of the broad thoughts again, that smart city is more of a non-American phenomenon. It is European Union, it could be Asian, it could be Latin American, again, in different forms of whatever the smart city smart means. And there are good reasons for that. United States has been a very advanced capitalist market, and that's how the federal government has worked. That's how the state government has worked. That's how even when the lobbyists from Silicon Valley go up to DC, they're all about deregulation. It's not about having any kind of a regulation unless their market value can increase, like those of having federal protections, federal privacy laws, rather than having states' privacy laws. And of course, there's much of a big difference in terms of the governance, that the American side is much more about competition and market forces, and what we are seeing on the EU side more broadly is on the coordination and equity side. All of this kind of says that no one shoe fits all. It's cultural, it's political, it's economic, it's responsive to whatever the local conditions are. And how that develops over the longer term would be interesting to see what that divergence looks like. So with that, we guess rest. Was that enough of a increase?
Thank you very much for your presentation. If there are any questions or comments to this presentation, please, Professor Rabia.
Thank you very much. Very interesting. All of the presentation are very interesting. Of course, I was exposed to one of them from before, so that's why I was not asking any question. And with the other one, maybe we will discuss further on the break. But regarding this last one, I don't know, was an optimistic approach to the European sort of smart city concept, or on the US smart city concept? I had no idea actually, and still a bit confused if you were emphasizing the benefits of EU approach of the benefits of US approach. If you can clarify this with me, maybe not that straightforward, but just, I mean, is it not necessarily of yourself alone, but your peers, people in US are seeing the EU approach more beneficial, or is it like, sort of?
Yeah, I was being political in saying what I was saying in that as well. There are both ups and downs, both sides. If you look at it in terms of pure commercialization, individual firms, if you look at it even in the AI market, the American market is much bigger than the EU market. The number of startups on AI are much larger in United States versus here. And that's for good reasons, because there are too many regulations here. Too many regulations constrain. That is the Wild West. So they can do what they do, disrupt first, then address the problems later. But here, you have to address the problem before you even think of disruption, right? So that kind of puts a pause on what the firms can do. So the firms out here rather be based out there because you have a higher degree of those venture capital available. They have the Wild West. They can do what they can in the healthcare market. They can do what they can on the transportation market. They can do what they can in all other markets. You don't see that much of that growth out here because the regulations come first. So whenever I was part of the conversations in the DC, and they were essentially saying, we don't want to go the European way. That's the old market. That's telling by itself. And part of this, the European, again, I'm going to be not political now. The European side in terms of the regulation feels good. But is that practical and is that good for innovation? That's a different question.
Somehow stops innovation, not stops, but very fun. Maybe.
We have another problem in Europe, and that is that our cities are quite old, which means that when you try to build new infrastructure, you will get always into these problems about cultural heritage and that kind of things. So I'm more thinking that we should maybe talk more about smart districts when you rebuild parts of the city and see how you can optimize like mobility and infrastructure. I think maybe the smartest city I know about is in Saudi Arabia because they built a city from scratch. Yeah, but they started from zero, and that gives a lot of more opportunities to make the infrastructure good for being smart. So yeah, and in the United States, the cities are younger and more space in many places. More land, yes.
Yeah, that's some of those differences which are coming up. The examples of Masdar and Dubai and Songdo, which we are mentioning, are also interesting. I did not go into the global smart cities out here, but if we go into the global smart cities, if you look at those are top down. That's essentially government which is pushing it down. But again, the Songdo, if you look at it, it's the American entrepreneurs who are investing heavily in there. Yeah.
Thank you very much. There are other questions? If not, I wish to thank you. And with this, we are closing this morning plenary section. I thank you individually for each presenter. They were very nice and interesting presentation. And with this, we are closing and we have a break. Then we continue with other sections. And 6th floor, yes. Thank you very much for your presence.